Teleportation will commence in 5 minutes. Do not leave any luggage unattended. Unattended luggage will be removed and destroyed. Attention, ladies and gentlemen. This is an announcement from planet X31. Please take your seats. Teleportation will commence in 2 minutes.
Columbia, this is Houston, ALS, over.
Exercises to test the reactions of troops to atom bombs used in support of an attack.
Drones like each other to different degrees.
Lower right, lower right.
Possibly interesting, yeah, but I like that.
Good evening, Earthlings, and welcome to the Science and Cocktails. Science and Cocktails is an initiative taken in collaboration with the Niels Bohr Institute that tries to bring scientific research directly to the people without interference of any other type of intermediate media. It tries to create a night culture that revolves around knowledge, entertainment, discussion, cocktails, and art. The last episode of this autumn season 2012 of Science and Cocktails will be presented by Henning Haack, a curator for the Natural Histories Museum Meteorite Collection. His talk will be about the 75,000 tons of natural space debris that hit the Earth every year and may result in shooting stars or in a possible ending for mankind. Later, Lars Lundhave Hansen, electronic music composer and sound designer, received an honorary mention from the prestigious Ars Electronica, will present some of his soundscapes which will take you to some other part of the universe. Abstract thoughts will be transcribed into images by the artist Henrik Schultz. And
okay, let's give an applause to Professor Henning Haack. Fantastic introduction, unlike anything I've ever seen before for a talk. My name is Henning Haack. Here's the sound. My name is Henning Haack. I'm curating the meteorite collection at the Danish Natural History Museum. So I work on the origin and evolution of the solar system. Sometimes we're fortunate to have little pieces of space falling on Earth. Sometimes they're a bit bigger, as you see here. I don't know if you've wondered about how frequent this happens. This is the way the Earth grew 4.5 billion years ago. The reason why we're here is that the Earth grew by attracting space debris, small and bigger pieces like this one. So it has a very important historical aspect. That's why we're here. And it has continued to happen. It still happens every once in a while that we have a fresh meteorite fall on Earth. And it also still happens that we have these events. There's been events like this in the not too distant future, and there will be events in the future as well. We can guarantee that, but fortunately there's nothing in our immediate future. But as Jay said, there's quite a bit that actually falls every year. And sort of the estimate is 75,000 tons per year, which sounds like a whole lot. But then again, the Earth is a big planet. So if you calculate how much it is per square meter, it's by 0.1 milligram per square meter. So this possibly sounds a bit less frightening than the 75,000 ton we have per year. But that's just the average. On a normal year, we'd have 75,000 tons in the form of gravel or sand-sized bits, and a few maybe in the kilo to ton-sized, but nothing like the asteroid we saw before. Those big ones are fortunately quite rare. But if we look at this object, I'm sure you're familiar with, our own old moon, it's quite obvious that it's been hit countless times. These old highland terrains, the bright parts of the moon, they're just totally covered in craters, saturated in craters. And that has taken about 4 billion years to produce a terrain like that. The Mare, you can see, there are much less craters. So we can immediately deduce that they must be much younger. They haven't experienced as long time as the highlands. So there's been less time to bombard them, and they're 2 to 3 billion years old. Still a lot older than the average surface on the Earth. And that's also why we don't see all that many craters on the Earth. It's one of those things where it took geologists a long time to realize that this is not just some exotic phenomenon that happens on the moon and all the other planets. It does in fact also happen on our own planet. The first crater that was recognized as an impact crater on the Earth only dates back to the 60s, and that was the famous meteor crater in Arizona. Again, I'll show you that in just a little while. But now we actually have a number, more than 200 craters worldwide that are recognized impact structures. Some of them quite big, and some of them have had quite an impact on the evolution of life on Earth. So I'm going to show you a few of these as the talk goes along. One very famous over here is the Yucatan Peninsula. That was an impact that happened 65 million years ago when the dinosaurs became extinct. That may sound like an awful long time ago, 65 million years ago, But remember that the Earth is 4,571 billion years old. Billion years, sorry. 4,570 million years ago. So 65 million years ago, that's actually those kind of timescales. That's in the very recent past. And the solar system looks just the same today as it did 65 million years ago. Okay, yeah, here's the crater I was talking about. That's the Arizona crater. It's 1,200 meters across, some 150 meters deep. If you ever been to the Grand Canyon or want to go there, then you probably would be driving along the highway over here and head north to Grand Canyon. You should really also take the road south and walk around this crater. This is really the closest thing you can get to walking on the moon. And in fact, the Apollo astronauts also trained here, because this is really something that looks a lot like the moon. This was formed some 25,000 years ago when a iron projectile, some 50,000 tons, hit the Earth. 50,000 tons. It sounds, again, that's about the same as the Earth receives every year from space. But if you calculate how big an iron projectile weighing 25,000 tons, it's only like 20 meters across, I think. So maybe it sounds a bit strange that it could create a crater which was 1,200 meters across. But the thing is that these objects come in at much higher speed than if you just throw a steel ball in the sand on the beach. You usually create a crater that's about the size of the ball. But in this case, when the projectile comes in at 20 kilometers per second, that's a typical speed that it will hit the Earth with. So you're talking about 25,000 tons traveling at 20 kilometers per second. The atmosphere protects us from all the little stuff. It slows it down. When you see shooting stars, you see stuff that slows down and fall slowly here. But if you're looking at something that's that heavy, then the atmosphere can't shield us. So it hits the surface of the Earth at roughly the same speed as it hits the top of the atmosphere. And just like when you brake on the freeway and you probably never touch your brakes after that, but if you would, the brakes would be very warm, I'm sure you're aware. That's just from slowing down from 100 or 130 kilometers an hour. If you slow down from 20 kilometers per second, then that energy, the movement energy, turns into heat energy, and that's much more than you need to vaporize those 25,000 tons of steel. So what happens is that the projectile penetrates the surface of the Earth and then it vaporizes. And you have a vapor explosion with 25,000 tons of steel vapor that shoots out through the surface. And that's what creates the hole here. The Arizona crater is very famous, but there are other very beautiful craters. This is northern Quebec. Very few people go to see that. So that's actually 4 kilometers across. So we have some very obvious craters, and it seems a bit strange that geologists didn't realize that these are actually impact craters till all the way up to the 60s. Okay, so what I had in mind to talk about today is to give you a little tour of impacts from the tiny pebbles, and those are the ones that I work a lot on. I brought a few of the little pieces that we work on at the museum. This one in particular is composed of the most primitive material we have from the origin of the solar system. It includes particles that we have dated to 4,567.3 million years. It's the oldest solid materials that we have ever looked at. And it dates back to the very, very earliest phases of our solar system. So this is sort of our book of creation. Everything we need to know about the origin of the solar system is in this rock. We haven't really understood exactly how to read the text. It's a bit difficult to read part of the details. It's written in the language we call geology. So if you're very good at reading geology, you can read all bits and pieces out of this. This one fell in Mexico in 1969, and we collected about 2.5 tons of it. And even today, many years later, we have several hundred publications based on research on this rock. So there's a lot of information. It's not just something that we put on a shelf in the museum. It's actually something you can keep getting better at understanding with better and better tools and better theories. So this is very interesting. And another interesting thing happened in 2009 where there was a meteorite fall in Denmark in Maribo, down on Lolland. So I'm going to tell you a little bit about that. That was only 30 grams, so it was a very different event from the one I started out with. Then we go to the slightly bigger, Tunguska. That was the biggest impact in historical times. That was back in 1908 when something very big hit the atmosphere over Siberia. I'm going to tell you a little bit about impacts sort of in the within driving distance from Copenhagen. At least if you spend a few hours, you can get to some of these impact craters. So you can actually see stuff in our neighborhood. And also talk about something that's happened in the last few million years in terms of impacts on the Earth, just to show you that this is not something that just happened back in the time when the Earth was born. This is something that's a continuing process that's still happening. And then, of course, you can't talk about asteroid impacts without talking about the events that happened 65 million years ago. So I'm just going to go a little bit over that. And then a little peek into the future. I'm sure you've seen that every once in a while there are stories in the news that now we found an asteroid and it seems it's going to hit us. And one of the best candidates right now is one that could hit March 16, 2880. I don't think anybody here needs to be too concerned about that. But unless medicine makes a giant leap forward, then we're probably long dead at that time. But then again, it's not too far away into the future. So I'm just going to show you a few of the theories of what could happen and if that one actually turns out to hit. We don't know for sure, but it has a fairly high impact probability. Okay, so let's start with the small and harmless things that are just of interest to science. So this is a story about the thing that hit us January 17th, 2009, at 20:08 in the evening. What you see here is a frame from a video camera recorded in Skåne. There are many far-out places in Skåne, in Sweden. And this is in the outskirts of one of the most far-out places where there's a farmer that lives there, Roger Svensson. And you think that nothing much happens out there, but he was a bit concerned that when he woke up in the morning, he saw some tire tracks out behind his farm. So he obviously needed to know what the hell was going on when he was sleeping. So he had his brother install a very sophisticated surveillance camera to keep an eye on what was happening behind his farm there. So he has night after night after night of nothing and nothing. And then every once in a while, finally on January 17th, he really hit the jackpot. And I have to jump out here to show that to you. Oops. It's going to be like that. He just mounted his video camera in the most perfect direction, aiming at just that part of the sky where this Maribo meteorite came flying in through the atmosphere at a world record-breaking 28.5 kilometers per second. It's the fastest meteorite ever recorded on Earth. So that's quite dramatic. So notice that the entire foreground here is lighting up. It takes it about 4 seconds to slow down from 28.5 kilometers per second and to 0. We lose it down here at 32 kilometers above the ground. And you see it breaking up a couple of times. And what happens is that if you enter the atmosphere up, and we're talking about heights of 100, 120 kilometers above the ground. All of you, I'm sure you heard about Felix Baumgartner to travel to the edge of space. That was only at 40 kilometers. Now we're talking about more than 100 kilometers. It's very thin air up there. But still, if you're moving at 28.5 kilometers per second, it's very dramatic to hit the thin air up there. So it slows you down in 4 seconds. So going from 28.5 kilometers per second to 0 in 4 seconds. I tried to do the analogy of if you take your car and you at the freeway doing 110 and you go straight into a brick wall, the acceleration you experience there is about 100 times less than what the meteorite experiences. So it's pretty dramatic. So what happens is that it breaks up into many pieces several times. Whenever you see this, it looks like an explosion. That's because the meteorite breaks up into a lot of pieces that very quickly stop in the atmosphere and drop all of their energy. We imagine that there was about a meter-sized projectile originally, and all we found was, as I said before, just 30 grams. It may not have been everything that fell, but that was all we found. So this was very fortunate. The first story, of course, was that there was a meteorite that fell in Sweden, and that was quite obvious. I mean, this is taken in Sweden, and here are the trees, and you can see that the trail ends just behind the trees. But in fact, this was some 220 kilometers away. My entire family saw this. They were all looking out the window. I was the only one who had the back to the window, so I didn't see anything, which I still kind of regret. So I'm very glad that we have this video. Life is just not fair. But still, this was a fantastic, it turned out to be a fantastic day. We find about 1 meteorite per century. And since my career at the museum is probably not going to last a century, that's a bit much to hope for. So chances were, and I'd already done that calculation before, that I probably wouldn't have a new meteorite fall in Denmark during my career. So this is fantastic. It's only the 5th in Denmark, and it's by far the most interesting meteorite ever to be found in Denmark. And here you have it down here. It's a tiny little piece. Not very impressive looking. My wife thinks it looks like a piece of charcoal or something like that, which I guess is sort of true. That's still different, though, I would argue. So, yeah, what happened was that this fireball came in here. The video was recorded from up here. Lots of eyewitnesses here in Denmark and northern Germany saw it, and remarkably, there's even a picture taken from Holland, some 630 kilometers away, that also recorded this. Show you that. That was an all-sky camera that was set up, so it's sort of a half sphere made out of, or a mirror made out of, sort of look at like a half sphere, and then with a camera mounted on top of it, shooting down at the half sphere, and that way you can see the entire sky, so you see the horizon all the way around here. Of course, the reflection of the camera here. And down here, there's a little streak of light enlarged here. So that's the Maribor meteorite, 630 kilometers away. So these are really not just high up in the sky, but these are incredibly bright events. Then, of course, next day we had all these stories, and I wanted to find out where did it fall. Unfortunately, we had 550 eyewitnesses that recorded their eyewitness report website that we made for this. So when you put that on the map, you can immediately see exactly what was going on, or maybe not. This is just something about the directions that, I don't know if they've stopped teaching north and south in school anymore. At least 50% of the eyewitness records are dead wrong. And I have to confess that I came to the conclusion that this one had dropped in the Baltic, because I talked to people on the south coast down here, and they all said, well, we saw it, it's very bright, we saw it to the south and disappeared over the ocean. And the Germans said, well, we saw it to the north, it disappeared in the ocean. So after I had talked to many people that said that, okay, it probably fell, but it's now at the bottom of the Baltic, and there's no chance we're going to find it. So, frustration. But then, fortunately, we had a German, a specialist. I mean, they're very a lot of specialists in this world. This guy is a meteorite hunter, and he happens to be the best in the world. He has the world record of finding freshly fallen meteorites. And he lives in Berlin, so that's not very far away. He was unfortunately going through knee surgery on January 17th, so it took a little while before he surfaced. But then he rented a house here, and he went up there and talked to people. And he did something that I just hadn't thought about. I mean, if you want to find it, you want to see, sort of follow the trajectory across the sky and follow the trajectory. At the end of the trajectory, you find the meteorite. But well, that proved a bit difficult, as you can see. But the other thing you can talk about or ask people about is the sound effects. When it goes through the atmosphere at supersonic speed, obviously it delivers an enormous supersonic boom. And I always thought, well, you can ask people, did you hear something? Yes. Was it loud? Oh, yes. Or maybe it was not so loud. I mean, that doesn't make much sense to me, or at least it didn't at the time. But the thing is that when it comes traveling through the atmosphere over the Baltic, it's just like a ship that delivers a wake out to the sides. So there's one wake that's sort of going forward like this, one going forward, like this. But there's nothing going straight ahead. And what he discovered was that in Maribor, if you go to the western outskirts of Maribor, nobody heard anything. But 5 kilometers to the east, they were really frightened about these supersonic booms. So he said, well, this is the place with the biggest gradient in sound effects, so it's got to be right here. So he made a little box 10 by 10 kilometers, which gives you 100 square kilometers, and then started searching for this walnut-sized meteorite. That, of course, he didn't know existed. He was just hoping, and he didn't know what he was looking for either. So, but he's a very dedicated person. So he found it, and he looks quite happy. There he is. This was in a cherry plantation. Of course, you can't look for meteorites everywhere, those 100 square kilometers, because there are lakes, which is not a good place. There are forests with thick layers of leaves and freshly plowed fields and stuff. But this is perfect. This is somebody took care and cut the grass in the fall time, and 2009 was the last green winter we had. So he found it 6 weeks after it fell. You see, it's actually right here, which is kind of difficult to see, but that's where it is. It's been freezing and thawing a lot, so it was actually already broken. Well, actually what he told me was that he saw it there. It was one intact piece, and then he bent over, looked at it and touched it, and then it just fell apart. So he never took a picture before it fell into pieces. But this is what it looked like. Inside that we have dust from the origin of the solar system. So this really helps us. Inside this we found something new. I'm going to show you then just a little second. Let's see if this will... Oh, I thought it was going to be an animation. Well, anyways, doesn't seem to work. Too bad. Well, but imagine that we just go backward in time, some 4,567 million years. Here's our sun. It just ignited. Around it there was a disk of dust and gas and particles that was later to become planets. And actually the material that constitutes us was also somewhere out here, somewhere. And most of that went into planets. And here on Earth, of course, everything's been reprocessed. We don't have very old rocks on Earth, at least not from my perspective. Nothing less than 4 billion years. So we're sort of losing out on the first 500 million years of the evolution of the solar system. But part of it accreted or clumped together in small pieces that never had a geological evolution. And that's where our friend Maribor comes from. It consists of particles and dust grains that formed freely orbiting the sun. It didn't form on a planet or anything like that. These are all, each and every single particle in this Maribor meteorite and the other one I'm holding up here, are particles that just formed as individual particles. So each particle in this, and there are probably 10 billion particles in this one, each particle has its own story to tell. The other thing that he found when he brought it back to the summer house, he'd rented down near Maribor, and then after an hour it started smelling really bad of organic solvents in his house. He thought, what's fucking spilling something or what? And he realized that this was the meteorite. This was the first time in 4.5 billion years that it was heated to 20 degrees centigrade. And it started degassing the organic compounds that it had collected 4.5 billion years ago. So it gives us a sample of the organic chemistry in the desk around it. Not that there was life at that time, but there were some of the building blocks that could be useful if you want to create life. You may think that it's strange that it could still contain these volatile components. Why didn't it degas when it was burning up in the atmosphere? But the thing is that it only took 4 seconds. And if you ever baked potatoes in the oven, you know that it takes about an hour to make the thing moist inside. That's because it takes a lot of time for the heat to penetrate to the center. And in 4 seconds, even a tiny walnut-sized piece like the Maribor meteorite doesn't heat up inside. The stuff that gets hot just melts off and it blades off as it goes through the atmosphere, but the interior of the meteorite is still ice cold when it hits the Earth. And that's fantastic, because if it had been heated up, all the information it had protected for 4.5 billion years would have been lost just seconds before we collected it, which is an unbearable thought. But fortunately, that's not the case. The atmosphere takes care of most of the material. In most cases, everything burns up in the atmosphere, but when something survives, it's in real good shape. It's just like the way it was when the solar system formed. This is a little cross-section of Maribor, 5 millimeters, and that goes all the way from one surface on one side of the meteorite to the other. You see it's fractured here, and that was because of the heat when it went through the atmosphere. And each and every single of these little tiny particles can tell its own story about why we're here today. So this is something very interesting that I could talk about for hours, but I'm not going to do that. And yeah, just another thing, we found these little funny, it looks sort of like wood, pieces of layered material that obviously formed underwater. So it tells us something about the evolution of water in the solar system. And this is something we've never seen in any meteorite before. So there's something totally unique about Maribor that eventually will tell us something about the evolution of water in our solar system. We don't quite understand exactly what it is that it's telling us, but that's what we're working on. But that's the exciting thing about meteorite. Every once in a while you get a new chapter in the book, and once you've learned to read it, you can actually learn something very interesting about why we're here. Okay, yeah. Off to bigger stuff. Maribor was knocked off an asteroid. This is an asteroid called Gaspra. It's 12 kilometers across. That orbits the sun way out in the asteroid belt, and every once in a while pieces gets knocked off, and you can see little craters on the surface that show you that it gets hit from time to time, and then if you're lucky, a big chunk of that can hit the Earth, which makes me happy, and of course somebody may get less happy if they're hit by it. There's quite a few of these asteroids out here. This is a little picture of the solar system from up above with the sun in the center and the inner planets. We're here on this orbit. And Jupiter out here. And each green dot is an asteroid. And we know 250,000 of them right now. So you can imagine if you want to fly out to Jupiter, you need your windscreen wipers out here when you fly through the asteroid belt. But that's just because well, we scaled it down a bit. In fact, even here where it's densest, the average distance between the green dots is 1 million kilometers. So there's quite spacious out there. So those are the ones that deliver most of the meteorites. A few of them come from Mars and a few come from the Moon, but most of them come from this belt out here, and they can tell you a whole lot about how the solar system originated. But the other thing about these asteroids is that some of them actually take a course into the inner solar system. The green ones are on a safe course, but the red ones, they have an orbit that takes them in here, and they could potentially hit the Earth. And this is what we're a bit concerned about. So there are a lot of programs dedicated to finding these asteroids years and years before they actually hit the Earth, so we can do something about it. Some of the red dots are way out here, but they still have an orbit that would take them in here. So those are the ones that we should keep an eye on. Another thing that could happen, is comets. The blue dots are comets, and they're even nastier because everything else here goes the right way around the sun, but the comets, they have a habit of going the wrong way around the sun. That's sort of like meeting one of these ghost drivers on the freeway that take the other lane as everybody else. So not only do you hit them at very high speeds, but they also come from unexpected angles. And this may possibly be what happened on June 30th, 1908. Yeah. when a huge object was seen flying over China and up towards Siberia. Here's well, no pictures of that, but we have artists also back then that were drawing these things. And this is sort of still a bit of a mystery event. It took some 20 years before the first scientists got out there and actually took a look at it. Of course, they had the revolution in Russia, which I'm sure sort of diverted their attention for a while. So not in 1921 they made a first attempt, but didn't get out there because this is really, really far out. And in 1927 they finally got out there, and they thought they were going to find a huge impact crater and smoking and everything. And all they found was some trees that all lay sort of in a characteristic pattern, pointing their roots in toward the center of this area. And in the center they had what they called a telegraph forest. All the trees were standing, but all their branches had been knocked off. This was a big mystery until the atomic bomb in Hiroshima, where they also had similar things, and that was due to the air blast from up above that knocked the branches off when they hit the earth. Apparently something similar had happened here. Of course, they didn't know that at that time. Even here in Denmark, people were very surprised. This is a picture taken on the night of that day in Aalborg, and there were stories in the Danish newspapers that this was a very strange night. You could sit out at midnight and read your newspaper. Of course, this was almost midsummer, but still pretty unusual that you could read a newspaper at midnight, and everybody was wondering why it didn't turn dark that night. So, and they had no clue that anything had happened in Siberia. But as the rumors spread, people were beginning to talk about this peculiar event, and there were rumors that the English were testing some fancy new weapons up in the ice sea or something like that. But for years and years, nobody had a clue what had happened. And then this guy came around, quite a character, Leonid Kulik. He was the guy that went in there finally in 27 and mapped out the trees. This is what you see here. That's an area that's about 70 kilometers from here to here, and all the trees were fallen here, and they all pointed in toward the center here, where he thought he was going to find the object, but didn't find anything. This is a horrible area with swamps and mosquitoes and everything. Not really your favorite summer location, which is another reason why it took so many years before they got in there. They also found some of the trees. This is a tree that was actually scarred. So there was a huge fire when it took place, and the tree burned on the side facing the facing the fireball, but it continued to grow after that. Interesting enough, this was right about the same latitude as Copenhagen. So had the Earth turned another 1.5 hours before it hit, then it would have hit Copenhagen. Of course, you can always speculate about these things. But this is an area about the size of North Zealand, so I'm sure we'd heard much more about it if it had hit here and not in some very remote place in Siberia. So the idea is that we had a piece of a comet come in, and the comet tail sort of scattered around the Earth and scattered the sunlight. So this was why we saw this bright sunlight or bright evenings in Denmark and many other places in Europe. It penetrated down into the atmosphere, and just like our friend Maribo, it broke up in the atmosphere. But unlike Maribo, which was maybe a few hundred kilos, this was 1 million tons estimated. And since it was a comet, it broke up readily in the atmosphere. At about 8 kilometers above the ground, it completely disintegrated. And since it was broken down to gravel-sized pieces, these just stopped almost instantly. So all the energy was turned into heat. And the amount of energy that was released was about 200 times the bomb in Hiroshima. So this was a huge blast that then, and the pressure wave just knocked over the trees all over here. And there are actually still people that are searching. There's still a bit of an ongoing debate whether this was a comet or a fragile asteroid, and people are still hoping to find pieces here. They found a chemical signature, but never any solid objects. So apparently it totally vaporized back in 1908. So these are things that can actually happen. Bigger things, sort of in our neighborhood, are also to be seen on this map. One I just wanted to point out is down here in southern Germany, where I have the Ries crater. That's funny, one of my favorites. It's actually a double impact crater. There's a big one here, the Ries crater, and then there's Steinheim nearby. They formed at the same time, some 14.5 million years ago. It's not, again, not too far apart back. And there was apparently an asteroid with a moon that hit the Earth at the same time. And Steinheim is sort of easy to see here with the central peak. There's they caught it at just about the right time of the year, where there's snow cover on the rim of the crater and the central peak, but not in the valley here. Some famous pieces of jewelry from that are these meteorites. Those are impact melts that formed when the projectile came down here, and of course the crater is gone. You can't really see it. It would have been nice with a real big crater, but 14.5 million years does a lot to the surface of the Earth, especially if we have ice ages. But when it hit the Earth, it melted many cubic kilometers of the Earth's surface, and these melts were scattered out. And especially in Czechoslovakia, you find these pieces of molten glass and look like Danish green beer bottles. That just happens to be the composition of the surface here in the Ries crater. So you find these pieces of glass in Czechoslovakia or in the Czech Republic. But what they really are pieces of melt that formed 4.5 million years ago when the Ries crater formed. So this is something you can actually see. The church here in the middle of this old medieval town of Nördlingen, in the middle of the crater at the central peak, was built out of debris from the impact crater. You can see big pieces that were thrown out when the projectile fell. And also other places in our neighborhood, the Siljan crater, if you've been skiing or doing anything else up there. It's another famous impact crater. And just over here in southern Skåne, there's a lake called Mien, which is also an impact crater, which is kind of hard to see though, but that's also a recognized impact crater. More exotic things are to be found up north of Norway. There's an impact crater that was found when they were exploring for oil, and they've named it Mjølnir. This is Thor's hammer, of course, which is very appropriate for an impact structure that hit very hard up here some 142 million years ago. So this is still a bit way back. This was caused by an asteroid 1 to 3 kilometers across. So now we're talking slightly bigger stuff. And just imagining what does actually happen when an asteroid a few kilometers across hits the ocean. That's obviously not so nice. You don't want to be in a boat up there when it happens. This is in Norwegian, of course, but this is a animation, or not an animation, or a calculation of the tsunami wave that you produce when you hit something like that. And you can see the wave height is up to 250 meters. So this is quite dramatic. In fact, it turns the sea bottom turns all dry for a short while. Just when it happens. So not a good place to go to Nordkapp and see the midnight sun. There's another of my favorites here that's down in southwest of the tip of Cape Horn, South America. And that was actually not that long ago. It's 2.1 million years ago. And there's a bit of a debate exactly how big the asteroid was. 4 kilometers here, another estimate, I think, puts it at 1 kilometer. But again, here's an animation of what happens. You have the asteroid come in, and it actually disintegrates when it's going through the water. All you see here is water, so this is the sea bottom down here. It's 5 kilometers deep. So it completely disintegrates, and then it makes a hole, so you can see the bottom of the sea 5 kilometers below the sea surface. It's totally exposed for a while. And you have the original wave here is, I think, some 5 kilometers tall. And again, this is only, well, I don't know, 2.1 million years. That's actually not that long ago. Again, it's in a situation where the solar system, the abundance of these things were exactly the same 2 million years ago as they are today. So this couldn't happen tomorrow because we think we know where these kilometer-sized bodies are, but it could happen in a few thousand years easily. So a massive tsunami just went on a destruction path up through the Pacific, and even in Europe this would have been quite easily recorded. Okay, so let's go even further back. There was this impact 65 million years ago, and this is, of course, we don't have paintings, well, we don't have pictures of that, so some of the people who work on this are also painters, so they've been trying to show the story of this. So it hit just off the coast at the Yucatan Peninsula, and it created a crater which is 200 kilometers across, and the initial cavity was 50 kilometers deep. So imagine a hole that's almost 200 kilometers wide and 50 kilometers deep. That's pretty dramatic. It also melted an estimated 15,000 cubic kilometers of the target material or the Earth's surface. 15,000 cubic kilometers of topsoil on the Earth melted at that time. And of course that filled the hole, and then the ocean flooded into this hole, which was filled with 15,000 cubic kilometers worth of molten material. So you can imagine the explosions and the things that were going on after that. Very big disaster. Not so much for of course, those that lived in the immediate vicinity, they would have been annihilated immediately. But the big disaster was actually all the stuff that got thrown into the atmosphere, because for about 10 years after this event, nobody could see the sun. It's still just a needle thing on the Earth. The Earth doesn't care at all. You can't destroy the Earth with a 10-kilometer asteroid like this. But it has a huge impact on the stuff that lives on the surface. So when you shut off the sun, then of course all the plants die. In the long run, they survive because they have seeds and can easily survive for 10 years. But then, of course, the plant eaters die off, and then the predators die off. So in the end, 75% of all species on Earth became extinct at that time. And of course, the remaining 25% of the species, they weren't happily living after this. Probably 2 or maybe 4 of them survived and could sort of continue their evolution. So this was a very lonesome place after this event, and the question is not why they died, but the question is really how did some of them actually survive. And we're very fortunate. This happened in faraway Mexico. Well, not at the time. It wasn't actually, not so far across the Atlantic. The Atlantic was still opening at the time, but many thousand kilometers away. The best place on Earth to see this is down here on Stevns. You can see the boundary layer is right here. If you've ever been to Stevns, you can easily see it. It's right there. There's a black layer of soot and clay right here. And all that black stuff, that was the stuff that fell out of the sky after this event. And it's still soft to the touch, unlike any other locality in the world where this is hard rock and very difficult to study. If you go really close, see, well, yeah, I have to update this. They change coins all the time. This is, of course, a way outdated coin, but it's a few centimeters thick here. Then, for many years, every geologist could see that this was a big disaster, and you could tell that the number of species down here were much, much higher than the number of species up here. But they had no clue how long time did it take. Was that millions of years, or thousands of years, or an afternoon, or what was happening there? But then, going back to the start of the talk, we had 75,000 tons of material hitting the Earth. And one of the rare things that hit the Earth is an element called iridium, which most of the iridium on the Earth is down in our core, so there's nothing on the surface. So all the iridium on the surface is something that falls. So we just measure the amount of iridium in this layer, and then we can calculate how many years did it take. Curious things was that they found about 1,000 times more than they thought. So either this had taken eons to fall, or the amount of material that was that fell from the sky during this event was just orders of magnitude more. So this started the search. This made people realize an asteroid must have hit us. That's the only way you can accumulate that much iridium. And then they searched for 20 years before they found the crater in the Yucatan Peninsula. So now we're pretty sure that we understand what happened. So yeah, that was a disaster for these guys. Word has it that they probably would have become extinct anyway because they weren't really declining at that time. They weren't smart enough, maybe, or who knows. The climate was not too stable either, not back then either. So at different times, maybe it wouldn't have killed them off. But as the situation was 65 million years ago and this huge impact happened, it killed off the dinosaurs. So that was clearly a disaster for the dinosaurs. But it was a blessing for others, because what happens with some of those that actually survived, let me just see, were the mammals. After this event, mammals just spawned. And so this is really why I'm giving this talk today. Without this event, mammals wouldn't have been the mammals we know today, and humans, well, we wouldn't have been here. I have no clue who would have been here. But when you wipe clean the table like that, then certainly life takes a different route. So that's why we're here today. So yeah, asteroids are good. Or maybe not. Of course, another one right now wouldn't be too good. This is just a little, I'm almost done. This is a chance per year. The big ones are fortunately the rare ones. An asteroid the size, the one that hit the Earth 65 million years ago, happens every 100 million years. But then again, it takes out about 10 to the 10 people. So it's on the average, it's 100 people per year. That's about as many as airline crashes, fatalities in airline crashes. So it's actually the same order of magnitude. But then again, it probably won't happen in our lifetime, so maybe we shouldn't worry. But I think it's still a good reason to just keep an eye out and see if there's anything out there that we should be concerned about. Much more frequent are Tunguska-like events that happen sort of maybe 2 or 3 per century. So this is something we could actually see again. Yeah, and then finally a little peek into the future. We have this one that may or may not hit us, March 16th, 2880. We have no clue where it's going to hit, but, well, let's pick a choice. And of course, the Americans have decided it's going to hit off the US coast. Makes it much more interesting. And again, that sends a terrifying tsunami across the ocean. And here we're looking at wave heights up to 65 meters, even several hundred kilometers from the impact point. Yeah, you can see half an hour and see how it spreads across the Atlantic. Some here, like here on the coast right there, you have a maximum height 126 meters, which is still a concern if you have a beach house right there. So not so good. Yeah, 117 meters. There are big run-ups on the US coast, and this would be much worse than Sandy in New York, that's for sure. And even here on the other side of the Atlantic, fortunately we're a bit shielded by England and stuff, but it will also be noticeable. And here in Ireland, 23 meters, 20 meters. So pretty bad also, but not something that would wipe off us off the face of the planet. Yeah, and then I think I've spent my time. This is something that has happened in the past. It will happen in the future again, unless we're smart enough and we see it. If we can see something like that, an asteroid that would hit us in 50 years, we can actually do something about it. Shouldn't send out Bruce Willis. I don't know if you've seen Armageddon, and blow it off, and then you have a million pieces that are, each of them are pretty fatal, instead of just having one piece that you can sort of push to the side in a controlled way. I mean, the thing is that if you just push it, give it a little bit of push, then 50 years down the line, it's going to be way off to the side. It's just like touching a rifle when somebody is trying to hit a target 5 kilometers away. You don't have to touch very hard for it to go way off. Of course, you have to be damn sure that you know where it's going to hit, because otherwise it would have missed, and then you give it a little knock and it hits. So this is but I'm sure that funding for asteroid science would receive a major boost if we actually found something like this. So it's also good for science. Yeah, thank you.
So thanks a lot for this nice historical record of all the beautiful things that can happen to planet Earth. The great news. And so does anyone has any final words?
Final words?
I mean,